Please forgive my stutter. I do not have an editor, nor am I paid by YouTube. Introduction, Licensing, and Table of Contents. Map, Introductory Chemistry, Internet, 2020, cited 2022, April 18th. Available from https://geo/page/45050 chem.libretext.org/at go/page/45050. This text map is an introductory chemistry text aimed for a single semester or quarter beginning experience to the chemistry field. This text map surveys some of the basic topics of chemistry and should give students enough knowledge to appreciate the impact of chemistry in everyday life and, if necessary, prepare students for additional instruction in chemistry. The LibreText libraries are powered by MindTouch, which is a registered trademark, and are supported by the Department of Education Open Textbook Pilot Project, the UC Davis, the University of California Davis Office of the Provost, the University of California Davis Library, the California State University Affordable Learning Solutions Program, and Merlot. We also acknowledge previous National Science Foundation support under grants number 1,246,120, 1,525,057, and 1,413,739. Unless otherwise noted, LibreText content is licensed by CC by NCSA 3.0. Legal, have questions or comments? For more information, contact us at info@libretext.org or check out our status page at https://status.libretext.org. A textbook map is an attempt to facilitate use of OER by recreating the sequence of content of an existing textbook. This is a textbook map of the introductory chemistry textbook authored by Tro for one semester preparatory chemistry. Fair use licensing. Licensing title map introductory chemistry TRO close parenthesis web pages 190. Applicable restrictions non-commercial. All licenses found unclassified 87.9%, 167 pages. CC by NC 4.0, 5.3%, 10 pages. CC by NCSA 4.0, 4.2% or 8 pages. CC by SA 4.0, 1.6% or 3 pages. CC by 4.0, 1.1% or 2 pages. A detailed breakdown of this resource's licensing can be found in Back Matter Detailed Licensing. 1. Or Chapter 1, The Chemical World. Chemistry is the study of matter and the ways in which different forms of matter combine with each other. You study chemistry because it helps you to understand the world around you. Everything you touch or taste or smell is a chemical, and the interactions of these chemicals with each other define our universe. 1.1 The scope of chemistry. 1.2 Chemicals compose ordinary things. 1.3 Hypothesis, theories, and laws. 1.4 The scientific method, how chemists think. 1.5 A beginning chemist, how to succeed. 1.E Exercises. Chapter 2 Measurement and Problem Solving. Chemistry, like all sciences, is quantitative. It concerns quantities, things that have amounts and units. Dealing with quantities and relating them to one another is very important in chemistry. In this chapter, we will discuss how we deal with numbers and units, including how they are combined and manipulated. 2.1 Taking measurements. 2.2 Scientific notation. Writing large and small numbers. 2.3 Significant figures. Writing numbers to reflect precision. 2.4 Significant figures in calculations. 2.5 The basic units of measurement. 2.6 Problem solving and unit conversions. 2.7 Solving multi-step conversion problems. 2.8 Units raised to a power. 2.9 Density. 2.E Measurement and problem solving exercises. Chapter 3 Matter and Energy. 3.1 In your room. 3.2 What is matter? 3.3 Classifying matter according to its state, solid, liquid, and gas, etc. 3.4 Classifying matter according to its composition. 3.5 Differences in matter, physical and chemical properties. 3.6 Changes in matter, physical and chemical changes. 3.7 Conservation of mass. There is no new matter. 3.8 Energy. 3.9 Energy in chemical and physical change. 3.10 Temperature, random motion of molecules and atoms. 3.11 Temperature changes, heat capacity. 3.12 Energy and heat capacity calculations. 3.E Matter and energy exercises. Chapter 4 Atoms and elements. 4.1 Cutting aluminum until you get atoms. 4.2 Indivisible, the atomic theory. 4.3 The nuclear atom. 4.4 The properties of protons, neutrons, and electrons. 4.5 Elements defined by their number of protons. 4.6 Looking for patterns, the periodic table. 4.7 Ions losing and gaining electrons. 4.8 Isotopes when the number of neutrons varies. 4.9 Atomic mass, the average mass of an element's atoms. Chapter 5 Molecules and Compounds. There are many substances that exist as two or more atoms connected together so strongly that they behave as a single particle. These multi-atom combinations are called molecules. A molecule is the smallest part of a substance that has the physical and chemical properties of that substance. In some respects, a molecule is similar to an atom. A molecule, however, is composed of more than one atom. 5.1 Sugar and salt. 5.2 Compounds display constant composition. 5.3 Chemical formulas, how to represent compounds. 5.4 A molecular view of elements and compounds. 5.5 Writing formulas for ionic compounds. 5.6 Nomenclature, naming compounds. 5.7 Naming ionic compounds. 5.8 Naming molecular compounds. 5.9 Naming acids. 5.10 Nomenclature summary. 5.11 Formula mass, the mass of a molecule or formula unit. Chapter 6 Chemical Composition. 6.1 Prelude to Chemical Composition. How much sodium? 6.2 Counting nails by the pound. 6.3 Counting atoms by the gram. 6.4 Counting molecules by the gram. 6.5 Chemical formulas as conversion factors. 6.6 Mass percent composition of compounds. 6.7 Mass percent composition from a chemical formula. 6.8 Calculating empirical formulas for compounds. 6.9 Calculating molecular formulas for compounds. Chapter 7 Chemical Reactions. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. Chemical reactions encompass changes that only involve the positions of electrons in the forming and breaking of chemical bonds between atoms. With no change to the nuclei, no change to the elements present, chemical reactions can often be described by a chemical equation. 7.1 Grade school volcanoes, automobiles, and laundry detergents. 7.2 Evidence of a chemical reaction. 7.3 Chemical equations. 7.4 How to write balanced chemical equations. 7.5 Aqueous solutions and solubility. Compounds dissolved in water. 7.6 Precipitation reactions. 7.7 Writing chemical equations for reaction in solution, molecular, complete ionic, and net ionic equations. 7.8 Acid, base, and gas evolution reactions. 7.9 Oxidation, reduction reactions. 7.10 Classifying chemical reactions. 7.11 The activity series, predicting spontaneous redox reactions. Chapter 8 Quantities and chemical reactions. How do we compare amounts of substances to each other in chemical terms when it is so difficult to count to 100 billion? Actually, there are ways to do this, which we will explore in this chapter. In doing so, we will increase our understanding of stoic stoichiometry, which is the study of numerical relationships between the reactants and the products in a balanced chemical reaction. 8.1 Climate change, too much carbon dioxide. 8.2 Stoichiometry. 8.3 Mole to mole conversions. 8.4 Limiting reactant and theoretical yield. 8.5 Making molecules, mole to mass or vice versa, and mass to mass conversions. 8.6 Limiting reactant, theoretical yield, and percent yield from initial masses of reactants. 8.7 Enthalpy, change is a measure of the heat evolved or absorbed. Chapter 9 Electrons and Atoms and the Periodic Table. 9.1 Blimps, Balloons, and Models of the Atom. 9.2 Light is visible electromagnetic radiation. 9.3 The electromagnetic spectrum. 9.4 The Bohr model, atoms with orbits. 9.5 The quantum mechanical model, atoms with orbitals. 9.6 Quantum mechanical orbitals and electron configurations. 9.7 Electron configurations and the periodic table. 9.8 The explanatory model of the quantum mechanical model. 9.9 Periodic trends, atomic size, ionization energy, and metallic character. 9.E Electrons in atoms and the periodic table, exercises. 10. Chemical bonding. How do atoms make compounds? Typically, they join together in such a way that they lose their identities as elements and adopt a new identity as a compound. These joins are called chemical bonds. But how do atoms join together? Ultimately, it all comes down to electrons. Before we discuss how electrons interact, we need to introduce a tool to simply illustrate electrons in an atom. 10.1 Representing valence electrons with dots. 10.2 Lewis structures of ionic compounds, electrons transferred. 10.3 Covalent Lewis structures, electrons shared. 10.4 Writing Lewis structures for covalent compounds. 10.5 Resonance, equivalent Lewis structures for the same molecule. 10.6 Predicting the shapes of molecules. 10.7 Electronegativity and polarity, why oil and water don't mix. Chapter 11 Gases. Gases have no definite shape or volume. They tend to fill whatever container they are in. They can compress and expand, sometimes to a great extent. Gases have extremely low densities, a 1,000th or less of the density of a liquid or solid. Combinations of gases tend to mix together spontaneously. That is, they form solutions. Air, for example, is a solution of mostly nitrogen and oxygen. Any understanding of the properties of gases must be able to explain these characteristics. 11.1 Extra long straws. 11.2 Kinetic molecular theory, a model for gases. 11.3 Pressure, the result of constant molecular collisions. 11.4 The combined gas law, pressure, volume, and temperature. 11.5 The ideal gas law, pressure, volume, temperature, and moles. 11.6 Mixtures of gases. Why deep sea divers breathe a mixture of helium and oxygen. 11.7 Gases and chemical reactions. 11.8, Boyle's Law, Pressure and Volume. 11.9, Charles's Law, Volume and Temperature. 11.10, Gay-Lussac's Law, Temperature and Pressure. 11.11, Avogadro's Law, Volume and Moles. Chapter 12, Liquids, Solids, and Intermolecular Forces. In Chapter 6, we discuss the properties of gases. In this chapter, we consider some properties of liquids and solids. 12.1, Interactions between molecules. 12.2, Properties of liquids and solids. 12.3, Surface tension and viscosity. 12.4, Evaporation and condensation. 12.5, Melting, freezing, and sublimation. 12.6, Intermolecular forces. Dispersion, dipole-dipole, hydrogen bonding, and ion dipole. 12.7, Types of crystalline structures. 12.7, Types of crystalline solids. 12.8, Water, a remarkable molecule. Chapter 13, Solutions. Solutions play a very important role in many biological, laboratory, and industrial applications of chemistry. Of particular importance are solutions involving substances dissolved in water, or aqueous solutions. Solutions represent equilibrium systems, and the lessons learned in Chapter 12 will be of particular importance again. Chapter 12, Quantitative Measures. Solutions represent equilibrium systems, and the lessons learned in Chapter 12 will be of particular importance again. Quantitative measurements of solutions are another key component of this chapter. 13.1, Prelude, Tragedy in Cameroon. 13.2, Solutions, Homogeneous Mixtures. 13.3, Solutions of solids dissolved in water, how to make rock candy. 13.4, Solutions of gases in water. 13.5, Solution concentration, mass percent. 13.6, Solution concentration, molarity. 13.7, Solution dilution. 13.8, Solution stoichiometry. 13.9, Freezing point depression and boiling point elevation. 13.10, Osmosis. Chapter 14, Acids and Bases. Acids and bases are common substances found in many everyday items, from fruit juices and soft drinks to soap. In this chapter, we will examine the properties of acids and bases and learn about the chemical nature of these important compounds. We will cover pH and how to calculate the pH of a solution. 14.1, Prelude, Sour Patch Kids. 14.2, Acids, Properties and Examples. 14.3, Bases, Properties and Examples. 14.4, Molecular Definitions of Acids and Bases. 14.5, Reactions of Acids and Bases. 14.6 is missing from my table of contents. 14.7, Strong and Weak Acids and Bases. 14.8, Water, Acid and Base in one. 14.9, Buffers are solutions that resist pH change. 14.9, the pH and pOH scales, ways to express acidity and basicity. 14.10, acid-base titration. Chapter 15, Chemical Equilibrium. In previous science classes, you may have learned that one way to distinguish chemical changes from physical changes is that physical changes, such as the melting and freezing of water, are reversible, but that chemical changes are not. In this chapter, we will see that this simple answer is not necessarily what it seems. 15.2 15.1 is missing from my table of contents. 15.2, the rate of a chemical reaction. 15.3, the idea of dynamic chemical equilibrium. 15.4, the equilibrium constant, a measure of how far a reaction goes. 15.5, heterogeneous equilibria, the equilibrium expression for reactions involving a solid or a liquid. 15.6, calculating and using equilibrium constants. 15.7, the effect of a concentration change on equilibrium. 15.9, the effect of a volume change on equilibrium. 15.10, the effect of temperature change on equilibrium. 15.11, the solubility product constant. 15.12, disturbing a reaction at equilibrium. Le Chatelier's principle. 15.12, the path of a reaction and the effect of a catalyst. Chapter 16, oxidation and reduction. 16.2, oxidation and reduction, some definitions. 16.3, oxidation states, electron bookkeeping. 16.4, balancing redox equations. 16.5, the activity series, predicting spontaneous redox reactions. 16.6, batteries, using chemistry to generate electricity. 16.7, corrosion, undesirable redox reactions. 16.7, electrolysis, using electricity to do chemistry. Chapter 17, radioactivity and nuclear chemistry. Radioactivity has a colorful history and clearly represents a variety of social and scientific dilemmas. In this chapter, we will introduce the basic concepts of radioactivity, nuclear equations, and the processes involved in nuclear fission and nuclear fusion. 17.2. 17.1 is missing from my table of contents. 17.2, the discovery of radioactivity. 17.3, the discovery. Again, 17.2, the discovery of radioactivity. 17.3, types of radioactivity, alpha, beta, and gamma decay. 17.4, detecting radioactivity. 17.5, natural radioactivity and half-life. 17.6, radiocarbon dating, using radioactivity to measure the age of fossils and other artifacts. 17.7, the discovery of fission and the atomic bomb. 17.8, nuclear power, using fission to generate electricity. 17.9, nuclear fusion, the power of the sun. 17.10, the effects of radiation on life. 17.11, radioactivity in medicine. Back matter, index, glossary, detailed licensing.